Okay. So everybody can see it, right? Hayati, you can see, right?
Yeah, Farah, it's visible.
Yeah, fine. So as been explained before, I have 8 years of working experience as a deputy manager. So not currently I'm working as a deputy manager, but I have total 8 years of experience, both as a process engineer and then and the lab. I have done my chemical engineering from IIT Bombay, Masters in Chemical Engineering in 2011, and then I have done my BTech in Chemical Engineering from Mumbai University in 2008. Okay, so today I would be talking about these topics as you can see on the screen. So I'll be talking about what motivated me to become a chemical engineer and what motivated me for pursuing higher studies. Then what was my career path and what were the learnings that I have taken up during my journey, and then my work profile and lifestyle, and what are the key skills required for during when you're working, and what are the other job opportunities you can look for. Okay, the next is my big why as a chemical engineer. So during my school days, I was very much interested in physics and mathematics. So they were my favorite subjects, and of course, computer science also. But when I passed, like when my plus two got over, I was in a dilemma whether to go for the computer science or whether to go for physics related field. So when it comes to physics related field, you have only two options. One is chemical engineering, other is mechanical engineering. Okay, so I gave a thought, and my dad was like, no, you have to go for core engineering subjects because the core engineering subjects may sound tough, but when you go over the period of time, when you gain experience, your value will increase way much higher than doing the computer science or other field. So I said, okay, fine, let's take up. So I saw the subjects. I like this chemical engineering subjects is fully like it's not about chemistry, it's about only physics and maths. So I end up doing my chemical engineering bachelor's. Then what? Then once I entered, when I went to my third year, then I have to think about. I was in a dilemma, like what I have to take, whether I should go for the job or should I go for the higher education. If I go for the higher education, what are the options I am having? So I think you people might be going through the same situation now, like whether should I go for a job or should I go for a higher education. So for me, if you ask, I also had a job opportunity during my BTech, but I have not taken it up because I liked my subjects. I was very happy with what I was reading or learning. So I wanted to go more in advanced. I wanted to know more. So that curiosity, I chose to go for higher education. Then I wanted to go in core technical because of my interest. Now, based on the experience I have, what I wanted to say is when you want to choose a job after your BTech, you have to keep one thing in your mind. Like, see, you will have a lot of job opportunities. Definitely, you will have a lot of job opportunities. People will take hundreds of trainees after you pass your graduation. But at certain point of time, like after 2 years or 3 years, you might be in a situation like they'll be like if you want to grow or you want to see yourself get promoted, people will start comparing with you with the person who are having higher education and the one who is a graduate. So at that point of time you will get disappointed. Okay, it's not like same for all the companies. It's majorly this is what has been observed. Sometimes if the company is very happy with your performance, then definitely they will promote you, give you a double promotion, and you can go ahead with your career. But if it is not, then you will be stuck at that point of time. Then you will start thinking, should I go for masters or should I do some crash course in MBA or should I do some crash course for masters? And you will come back again doing the masters. So why to do that at that point of time? Even in fact you can do much better now. So think about it when you are taking a job, okay? But There is another disadvantage. No, disadvantage of the higher education is like, again, like you have a lot of opportunities when you passed out as a graduate, then you passed out as a master's. So you have to think like, what should I take? Like, should I okay with doing the job as a trainee and go along over the period of time, or should I go for the higher education, enhance my skills, and then go ahead with the job? It's all up to your decision. Okay. So now when you come to the higher education part, you have the two options. One is core technical and another is management. So why core technical? What is happening in core technical and what is happening in the management? I will show you in the next slide. One second, please. There are two options when you go for higher education in terms of career. Okay, so there is core technical and another is management. So when you opt for the core technical, the kind of jobs you will be looking at is for teaching, in research and development, in technical management, and in process development and designing. Okay, so all these core technical jobs are like require your knowledge and your thinking process for you to work. Okay, then when you go for management, you will be end up doing jobs for just hold on, right? Wait. This is not this one. Hello,
Yeah,
hello.
Farah. Yes.
Yeah, can
Yeah,
you
yeah,
see the
yeah.
screen? Huh,
Yeah,
okay.
it's good.
So yeah, so when you go for a core technical, your basics should be very strong. Okay, so then only you'll enjoy the kind of work you're doing, and you will grow and excel in your work. But when it comes to management, your skills are important. It's not like, see, when you go for management, it is not like you are completely going into another field or people are expecting you to do another kind of job. No, there are jobs who wants chemical engineering expertise, and then they want this management skills as well. Okay, sometimes some people, like in yourself only, you can ask question you to yourself also, like what is the kind of work I like. See, when for example, I'll say you are doing so many activities during your undergrad, right? Like you are involved in various, like, organizing this core talks is also one of the activity you are doing. So if you feel that you are very much interested, you are so happy to do this kind of jobs, but you want to stick to your core also, then you can go for the management kind of jobs. Okay, like there is something called project management department in any every office. Like from in my company, we have a separate project management department. They are also chemical engineers with MBA. What they do is, like, they will understand the requirements from the client, because if any simple MBA graduate person you put into the job, they might not able to understand the language what client is saying. Like, he will say what is their product requirement, what kind of what kind of reaction they want, what kind of product size they want, and all those, those technical language. So that thing can be understand someone who is good, who has this basic knowledge about the chemical engineering. Then using that, then he will project it. He'll try to communicate with the technical people and make them understand the requirements so that they can work on the same. So this is the kind of job you can do when you do MBA with the graduation in chemical engineering. Okay, so basically, you are good with basics, should go for core technical, and who are good with skills, communicating skills, talking skills, and all that, they can go for the management side. Now, coming to that was about the higher education and the career you need to choose. Now, I'll come to the work experience that what I my career path basically. I started my career as a process engineer R&D in PISO projects. So that was immediately after I passed my masters. So there I was into a complete desktop kind of job. Okay, my job was to do
Uh,
prepare this base. Yeah. So this is the work experience. This is my career path. Okay. So I started my career in 2012 as process engineer R&D in PISO projects. Uh, so there my work was completely desktop related. Okay. Some like I have got some questions saying that what motivated me to shift from desktop kind of job to the lab job, and I'll let you know in this slide itself. Okay, so there it was completely desktop job where I need to prepare the basic engineering documents. Basic engineering documents means like starting from making a block diagram, PFD, PNID. I think you people must be aware of all these terms. Okay, so then doing the sizing calculations and pump calculations, and keep making everything specific calculation sheet. These all things will keep it make a complete file and hand over to the mechanical engineering department people. From there they will take it up like doing the piping and piping related job, and so then civil engineering people will come into picture. So all these things will happen, then only you will have this final plant ready. Okay, so there are many things that are involved when you are designing or developing a plant. Okay, so that was the kind of job I used to do there. So for that, I used to work with Excel sheets, and Aspen, HISIS. These are the kind of things I used to work with in that kind of job at that time. But I was happy to do those calculations and all that, but I was more interested to go into research. That was the thing, it was there with me since starting. Okay. So then I shifted from there to DBT ICT. There I was having experience of both desktop and lab. Okay, but not that much of lab. I just used to go and observe in the lab how the process is going on, but not involved in the work there. But again, there also I need to prepare all those documents and talk with the clients, talk with the vendors, handle the complete project. So there I had a little more extra responsibility than the previous job. Then from there, I was in fact at that point of time I was completely involved in one project which we have done for IGL Kashipur to convert biomass into ethanol. So that was one interesting project I have done during that period of time. Then from there, I shifted to Hyderabad to CSR IICT. That I shifted because of some personal reason. But there I joined into the research study group as a project assistant. So there I was involved completely into the like I was doing lab work as well as I was simulating some of the results over there. Uh, what I felt over this job and that job is like when you are working in any industry or in a company, they you have, even if you're working in a research field, you will not have ample of time to do your own research. Okay, you will have a limited time. You need to get results within that scope of time only because you're answerable to client over there. Every week you will have a call, you will have an update, so you need to finish that work within 1 week of time. Whether you spend extra time, less time, it's up to you, but you have that time constraint. So sometimes what happens, even if you wanted to do more study or more experiments and all that, you'll be restrained with this time factor. And also you will have multiple projects. Okay, there are multiple things that are going on, so you might not be able to have 100% concentration over one project. But it's not like that you won't enjoy, it's not like that. It's like over the period of time you will know how to tackle with the projects, how to manage time. These are the skills that you need to develop over the period of time when you're working. Okay, so that is a difference which I found from when I was working as a project assistant in CSR IICT, and then when I working in the Syngene Biocon, in the same research field. Okay. So after that, when I joined as a senior research associate, as I told you, there was completely involved into the lab kind of work. I will let you know in detail in the future slides about the work which I was doing over there. Okay, so I would be, running here and there. That is one thing when you're working in the lab. You're not sitting at one place. Like like when you're doing a desktop job, you are working from 9 to 5, but when you're working in the lab, everything is unpredictable. Sometimes your reaction might take long, sometimes your results are not coming, sometimes some impurities have come and then you need to spend extra time to remove it. All these things you will be having some challenging works going on over there in the lab when you come into the lab kind of work culture. Okay. And then I next currently my role is I'm working as a deputy manager in Lab Sciences. And there I do work in lab, but it is comparatively lesser than what I was working in Syngin. I have more of managerial responsibilities like dealing with the clients or talking with the people. So that's how my career path has been so far. So good. Okay. So now what, like, everyone would like to know, what does the company want? What are they looking for when you go for an interview? I have jotted down some points based on the experience I had when I was giving interviews. So people would be, or when I was myself, had taken a few interviews. So when I'm taking an interview, I would like to look for the people who are confident and smart. Smart means I'm not talking about the way they are looking. Smart means how smartly they are answering the questions which I am posing over them. Okay. So your answer should be very precise. When someone is asking you questions, you should answer it very precisely, very smartly. So people will like that kind of candidates. And then good problem solving abilities. Okay, you should have very good problem solving abilities because see, whenever I used to go for any interview, the major question they used to ask, like, what kind of problems did you face when you're actually working in the field and how did you solve it? So you should have a very very good answers for that. You should always, sometimes what happens is when you're working, you will come across certain problems and you will be solving it, but when it comes to the interview, right, you won't remember that. You won't think, okay, that was the problem and that's how I solved it. So when you're preparing for any interview, try to jot down, try to think like how you have come up with the, like how you have come up with a solution for the problem which you have seen. Okay. So and how you will do that is also very important, which I will tell you in the future slides. Okay. And third point is people who are well versed with the job requirements. When you're going for an interview, make sure that you go through the job requirement or job description 10 times before you go for the interview, because majority answers lies over there only. When I am an interviewer and when I'm asking questions to the candidate, in my mind I'll be thinking that I have this thing, this post, and this is what the ability or requirement for the post, whether it is meeting or not, whether that opposite person is able to do that job or not. So try to match with the your abilities or your skills with the job requirement or job description which you come across. And also you should be aware what companies doing, where they are involved, like what kind of products they make, or what kind of solutions they offer, what kind of technology they do offer, and all that. You have to be well versed when you're going for an interview. And of course, you should have a very good or effective strong communication skills. Okay. But the other thing is that you should not oversell yourself. It is very very bad. Sometimes we, in order to impress the interviewer, we say so many things, that I know this, I know that, I also know this, I also know that. But the interviewer will not take much, within seconds he will come to know that you are lying. So please do not oversell yourself. Whatever you know, what are your abilities, what you can do, is what you can, what that is what you need to answer in your interviews. Okay, so try to be honest in your interviews. So that is the best skill. Hello.
Yeah, Farah, you're audible. Just, yeah.
So the next side is how do I work? What is my work lifestyle? What kind of work I do? Okay, I'll be telling about that. So basically, there are four things, four sections that are involved in my department or the kind of in my work which I do. So we have this process scale up, we have process safety, we have technology transfer, and we have quality by design. Okay, I will tell you each and everything in detail. See, what is process scale up is I work in a pharmaceutical company, right? So 80% of the people who are working over there are chemists. Fine. So they are developing the process. They are doing so many experiments and then they are even, doing the production work. So what is my role? What is the chemical engineering role over there? See, they know how to develop a process in the lab. They know how to do it in the lab. They are able to do at maybe at 1 gram scale or 10 gram scale or even 100 gram scale. But when you are scaling up to 1 kg or 10 kgs or even 100 kgs, you will have so many challenges coming in front of you. Okay. For example, like when you're doing a simple filtration in the lab, you will use filtration paper and a funnel, okay, to do the experiment. And simply you can you can see everything in front of your eyes, whether that your product is overflowing, not overflowing, how the things are happening, everything. Even you want, you can control. Suppose your reaction is going, your reaction temperature is going very high, you can immediately go and close off these burner and all that. But when it comes to a higher scale, when you're scaling at 10 kg, 1 kg, you have these big heat exchangers or big reactors. How would you go and do that kind of control, right? You cannot just simply go and close, turn off the burner. There's no burner, first of all, over there when you're scaling up. Like there are many things that come into picture when you're doing the scale up. So that is where the chemical engineering comes into picture. Okay, a chemical engineer basically design the process into a at the scale up level. Okay, when the process, like when you are doing a heating process in the lab, how would you do the same heating process at the higher scale by using heat exchangers, or you by using the heating reactors and all that systems. Okay, or when you're doing filtration in the lab, how would you choose which type of filter you will choose, what filter you will choose, what speed you have to do filtration, and all these calculations will come into picture. Or when you are doing a mixing process in the lab, you can easily do the control. But when it comes to the plant, you have to specify a certain rpm, certain speed of that agitator. So that and all calculations will come into picture when you are doing a scale up process scale up. Okay. So now that is all that, like we do certain studies in the lab. We'll see we have this kilos lab reactors. Okay, kilo lab reactors nothing but a mimic of the plant reactors. Like you have a reactor with the cooling. Fine. That's same reactor of maybe 500 ml or 1 liter we have in our lab, where we can run the reaction and see how it is behaving when we are actually running in the reactor. Okay, so that and all studies we will do. I'll explain this a little bit more in the coming slides. Okay, then the next factor we study is process safety. So what is process safety? Okay, there are two things. One is the uh, you will do that process safety study to avoid any hazards, like any thermal hazards. Okay, or and you will do that study to see what will happen in the terms of worst case scenario. Okay, so suppose I am doing a reaction. If I want to know how much of cooling is required for that reaction in order to control its exothermicity. So I need to do certain calculation, I need to do the reaction, I need to do this behavior. So for that I have to do some study. So that all comes under as a part of it, process safety. Okay. Now next is handling safety, like you're handling some hazardous chemicals, some dangerous chemicals. You want to know how to handle them, what kind of PP I need to wear, what kind of temperature I need to keep, and all those things we will study. Another factor is what happens if the suddenly there is a cooling failure and the reaction is going very high and there's a blast. Okay, the reactor blast. Then what is the consequences? How bad it can go? So that also comes as a part of that study also comes as a part of process safety. Okay, we do that. We try to we'll see what is the maximum temperature it can go before it go decompose, or it can before it blast, before it goes as a runaway reaction. So these are all things we do as a part of a process safety. Okay. Next is the technology transfer. Now, like now, as of now, we have done the process scale up. We have done all the studies. We are ready to go to the plant from the lab. Then we have done all the safety studies. We know what is bad, what is the maximum temperature we can operate at, and all those things we know. Now, use taking up all this knowledge, we need to transfer it to the plant people. Like plant people, we have all these production engineers, chemists. So many people will be there. They have their own managers, plant managers, and all that. So we need to transfer this data, how to operate or how to manufacture for that particular process. So we will do all this technology transfer. There is a protocol, there is a protocol, a way, a method to do this technology transfer. So it's a very very vast subject, I will not talk about that, but just a brief that this is the kind of work which is involved. Then next is the quality by design. Quality by design is something that is upcoming very fast in the pharmaceutical companies. It's like, see, for example, I will tell you, if I have a reaction and I want to optimize its temperature or pressure or concentration conditions, I might have to run that reaction maybe 10 times or 50 times in the lab, which is actually taking me a lot of time, which is actually taking a lot of money, right? Instead of that, you can design your experiments in such a way, like if I can do 4 experiments and do the optimization based on the 4 experimental data, then I'm actually able to save the cost of the company. Okay, and I have also able to save my time. So how to do that? There is a method to do that. There is a software that is involved into it. So that and all things we will do in quality by design. Okay. So suppose like I have a process in which I want my product to be maybe 80% pure. Okay. So for that to get achieve that 80% purity, I have to vary my temperature, maybe some, for example, 50 to 60 degrees, and some pressure maybe from 50 kPa to 100 kPa or something like that. Okay, so instead of doing for each temperature rise, I can basically run 2 or 3 experiments and then plot a graph, get that correlation equations, and then do the simulation and get the do the optimization and get the optimized results. Okay, so that and all we'll do as a part of quality by design. Fine. Now the next slide. Now coming to the more detailed work which I do in the lab, as I told, as a part of process scale up. Okay, so we have these studies that we do in the lab. So like we have this kinetic studies. Okay, we do these studies to find the time for reaction, then to find the optimum process conditions. Like I want to know how I can reduce the reaction time. If I or I want to know how to improve the concentration of the product, I'll do these studies in the lab. Then we have the exothermicity study. As I said before, that I want to know the worst case scenario. I want to know what will happen if the reactor bursts. or what is the temperature where it can go out of control. So to know that data, we have these small bomb calorimeters in the lab. So we'll run those reactions in those calorimeters. So and based on using that calorimeters, we will also find out what is the rate of addition. See, when you are doing a semi-batch reaction, okay, semi-batch reaction, like one reactant is already there in your solution and one more we are adding to it. So if we are adding to it, there is a rise in temperature. Okay. So and we don't want the reaction temperature to go beyond certain temperature. So that on all depends on the rate of addition. So if you're adding very fast or if you're adding very slow, then you should add at a time only. These are all things we will do a study using a calorimeter. Okay. So that will help us to, to get a effective control for cooling. Next is the decomposition. Sometimes what happens is when you are doing a reaction and it's an exothermic reaction, then the temperature of the reaction rises and the product or the reactants that are there in the solution, their temperature also rises and they are so some of them might be heat sensitive, so it will get decomposed and produce more heat or it might convert into impurity or other product. So you want to know that what is happening to those reactants and what is the maximum operating temperatures. So we will do this decomposition studies. So that we will do using the DSC, differential scanning calorimeter. Okay. Then we do the corrosion studies. Corrosion studies is to know the compatibility of your reaction solution with the reactor material which you are going to use in the plant. Like should I go for stainless steel 316 or should I go for stainless steel 306? Should I go for glass? These are all decisions we'll do based on the corrosion studies. So we will keep the, we have this chips of the material which of the reactor which are we are going to use in the plant. Those chips will keep in dip in the solution. We'll keep and we'll see. We'll observe how that is behaving. Then based on we have certain calculations, then based on that we will decide which reactor to choose. Then we have this mass transfer studies. We will see, like, we have these hydrogenation reactions. So we will see how the hydrogen is getting diffused in the solution based on the rate, like what at what rate we should pass the hydrogen into the solution, how the reaction is taking place, how much time it is taking place. So this is an all study we'll do as a part of a mass transfer studies. Okay. Next is the crystallization study. Like these are all belongs to the unit processes. That is all related to your reaction. Okay. Then when coming to unit operations, we have unit operations. Unit operations is like what? Like after the unit process, after the reaction is over, after you got the product, you need to separate it or extract it or filter it or crystallize it. These are the other operations you need to do. So for that, again, we have other studies. Okay, like for crystallization, we will find out the solubility curves. We will find the particle size distribution again, which is dependent on the temperature and pressure. So we do these studies. Okay, for all these, we have dedicated instruments available with us in our lab. So using that, we will find out all those information. Then we'll see the drying. We'll do the drying study. In the drying study, we'll see the drying rate for drying curve. Then we do the distillation studies. We'll find out how much time is required to distill the product at that required concentration. Then we have filtration studies, like if we are going to filter at the higher scale, what kind of filter and what size of the filter we need to use there, based on the data we'll get in the lab. Okay. And then we have the extraction studies. We'll find the distribution coefficient. So we find the time for the extraction, flow rate required, and all those things we will do. This and all is like, combination of both doing experiments as well as using softwares. So we have some softwares like Dynochem and one more I'm not remembering. Okay, mostly Dynochem. So we use that softwares to, do the scale up kind of studies. Okay, so that was that was about my work lifestyle. So basically, if you ask me, I'll be keep on running up and down stairs, running from lab to plan, plan to lab. Always on my toes. That is my work lifestyle in my current role as well as in my previous role. Okay, so if you're not the person who wants to run around, then you can happily go for process engineering kind of jobs. Okay. Fine. So now, what is that you need to have, uh, you know, to do your job well? What are the basic job skills? What is there beyond the basics? Like when you're coming for a job, everyone are good with their basics, but what is extra do we need to do our work or do a job? So there are many things, many skills, but out of which I feel is the one which is very important is the problem solving ability. Okay, so you should have a very, very good problem solving ability. So there is a method to do the problem solving ability. I'm not talking that this is only required for the research kind of companies, but it is also important for those who are working for in a process design or process development also. Okay, so there are certain steps when you're going for the problem solving. So that is like you need to define the problem based on the criticality and the safety. Okay, what is the problem? What is happening? What came into picture? This thing you need to define. After that, you need to do some background research. Okay, like what was the equipment design, what is its capacity, uh, you know uh, you have to look into that, or you need to look into the process, like what were the solvents, what are the temperatures, what are the conditions, limited conditions for the reactants and all that. So that is the background research you need to do for the problem. Then the requirements, what are the requirements, okay, what are the solutions for that. Then you need to discuss with your team. Then it's not like only chemical engineering team is involved. There'll be, when you're working in a plant, you have this mechanical engineering team, electrical engineering team, instrumentation engineering team, civil engineering team. You all need to sit together and discuss, like this is the thing, this is the problem and this is the solution. Then how should we go about it? Okay, then after the decision, we have to develop the solution. Then we have to test it. If it is fine, then well and good. If not, then again you have to iterate it back, and then you have to start from start uh, start it again. Okay. Now, what are the other job opportunities you can look for apart from this process engineering or the pharma companies which I have experience with? Okay, so what I feel is when I started after my BTech, at that time I have only seen process engineering design development or into oil and gas kind of jobs. But now, if I see now, like there are so many opportunities for chemical engineers because they are multidisciplinary. Means like they can work with like everyone. Every field requires somewhere some chemical engineering background to work with. For example, I can say, like, see, for pharma also, initially, if you ask me some 10, 15 years back, people used to say that we never worked with chemical engineers, we never wanted any chemical engineers, we used to work nicely, like that, like chemists used to say. But over the period of time, they want to make the process more effective, more cost effective, more robust, more advanced, more efficient. To do all these kind of things, to involve all these kind of things, chemical engineers are coming into picture. So they are not only doing only process design, they are into pharma, then they are into energy, they are into environmental, uh, they are into software also. Okay, now we have so many softwares that are related to chemical engineering that are getting developed, like Aspen, HYSYS, Dynochem, COMSOL. So they all require chemical engineers some way, so that they can use their basic knowledge to develop their own softwares. Okay, so what I feel that it's a chemical engineering is a very good field. You have a lot of opportunities. There are various fields you can get into. A lot of opportunities when you grow. Okay. Uh, so even when you say, like, even in the other fields, like in the electrical field, or companies like who are in different electronics, also they are also hiring chemical engineers. uh, this You have this company called KSET and Telcor, Kelet and Core. So they are into semiconductors production, but still they hire chemical engineers because they want someone who can understand the materials, right? So it's a very good field. You have a lot of opportunities when it comes to job. So that's what I found this quote very interesting. That although the future may appear murky, but what is clear is that as chemical engineers today, we must remain curious about the evolving environment and ready to adapt it by adding new skills to our repertoire. So, as the day is passing by, the demand of chemical engineers is increasing, and I feel that you keep on, developing new skills, keep on updating yourself, then you will have very good opportunities in future. That's all. So, I'm ready for the questions.
Great, Farah. That was a wonderful and quite informative for us. Okay, so you can type in your questions if you have any in the chat box while I'll ask whatever I got as responses to the form.
Mhm.
Okay, so Farah, the first question we have is that what differences do you feel there are between education opportunities and the exposure the students can get from your time and today?
Uh, See, education opportunities. I wanted to ask, like, whether they wanted to ask how people are opting for higher education before and now.
Yeah, similar to that. Like, are there more things they can explore in today's time? Is the exposure more today? What are your opinions on that?
Huh. See, before when I was doing my masters, the people did not go for masters that much. Like they used to go for job directly because jobs were available, competition was less. Okay, but as of now, if you see, for the same kind, like for example, for teaching, at that point of time, even masters was sufficient for some colleges to go for a teaching job. But now they require PhD because of the competition. People are coming with the PhD degrees for teaching. So why they would choose for someone who has done masters? So I feel that the more as time is passing, the more people are getting exposed to the are going exploring more higher education opportunities than previously.
Okay. The next question is that study in course and groundwork in the industry, which according to you is more lucrative and interesting?
Okay. See, it depends on the person what he is thinking. What I feel is when you're doing when you're going into the course study, you have your own time. Okay, your own time to think, and you will have very good results also because a time investment, like the time you have spent on one particular project, is you have a better results. But when it comes to the industry part, you have this time constraint. Okay, you cannot work for days together to get the results. People are not interested like that over. They wanted good results in the limited time. Sometimes what happens is, in order to achieve that, you need to cut short your research, you need to cut short your thinking process. You need to say, okay, if I achieve this 80% of the result, I'm okay to go with it. So these and all things will come when you are working on the industry. All that matters is time and the client satisfaction. But when you're working in the core study, you have your own time, you have your own like if you are patient enough, then you can work on that project for years together. Also, no one will ask you over there.
Right, right. Okay. What are the positions that a PhD should apply for in the industry soon after their PhD is over, and where can they look for such positions? Like, how should they go about the process?
Okay. See, if you ask me, uh, when you have completed your PhD, it's not like it's like 50% of the jobs are related to teaching. But apart from that, you can join as a scientist or a senior scientist in the research companies, or you can join as a manager, senior manager in the research in any other companies. Like basically, companies which are are big, they will hire PhDs very well. Okay, so yes, it's not like after PhD you will not have job. The jobs are there, but they'll be at a very higher level. So their expectations will also be at the higher level. So you have to be ready with the both the aspects.
Okay. What motivated you to change your field of research from process engineering design to research lab experience? Like, are they different, and what basically is the difference between them?
Okay. During my slide, I have answered that question, but still, as I told you, process engineering job was completely desktop kind of job. Okay, like normal office kind of job. But when I was working in the lab, it's like you have this. You are working in the lab. You're running around. All unpredictable things are happening. There is sudden problems, sudden challenges, and you have to be ready for that. So that is my observation. So it's up to you what you want. Whether you are okay, you don't want that kind of sudden kind of changes, then you are happy to go for process engineering job.
Okay. And nowadays, there's a very increased inclination towards non-core jobs like management, analytics, etc. So, do you think the core has enough opportunities to cater students, or why do you think
Yes.
this inclination is there?
No, no. See, even I was surprised. Like when I was doing my masters and for the placement for the especially for graduation, undergraduates, companies like McKinsey or JP Morgan are coming and hiring. There, those are all banking and financial companies. So, but see what happens is like when you are joining a company, at that point of time you are more attracted towards the salary they are offering or the job post they are offering. But when you join after 2 years, you'll start feeling like what am I doing? Like this is simple kind of job. I can actually do more, but I do not have any scope over there to do more. Okay, so you're stuck with the Excel sheet only. There's nothing else more beyond that. Okay, so you'll start getting bored, you start getting frustrated, and then you don't know where you will go. Either sometimes some people will compromise and stay there only, some people will leave and go for higher studies or do PhD, and it depends at that point of time. But still this question will comes into their mind, after 2 years. So that is what I want to say, is that when you're taking up a core field, I know the starting is very tough. You'll have many many challenges when you're actually starting, but over the period of time when you have gained experience, your value will increase 100 times. And trust me, nowadays field for there are many opportunities for chemical engineers, especially chemical engineers, because I am seeing that. I see, I have seen people calling me for interview from Capgemini, also from from IT companies, also from environmental company, energy company and all that, because they're expanding. Like they are seeing the skills of a chemical engineer and how can they use it in their own fields. So yes, I say that chemical engineering have vast opportunities. So don't regret or don't feel that why I have taken the core technical. Please be proud of that.
Yes, ma'am. And ma'am, one last thing. Your profile reflects that you've done a number of projects and explored research a lot in college. So, what suggestions would you have for the undergraduate students of second and third year? How should they go about increasing their interest in core or exploring it while they're still in college?
Okay. See, you have these opportunities to do projects, internships and projects, right? So you can explore more opportunities in that if you want to. And I don't know, when I was there, we have this thing, I'm not remembering this. We have small plant, right, where they for converting biomass to ethanol. I don't know now. Okay, at that time it was there. So I used to find that interesting. Okay, like they were developing this plant. So what happens is when you're working in a plant or when you're working doing some kind of that kind of work, you will come across various challenges which actually you will face when you're working. Okay, so try to take up such kind of projects where you can actually experience the industry, kind of work. So that is what I feel, and I feel that please stick to the core. Don't try to do unless you're up to see. Some people will have good skills in have good effective communication skills and presenting skills and all that management skills. They will be very happy when they go move out from this field. But when you're good with your basics, then you'll be more than happy if you stick to your core technical field. Okay, that is what I wanted to say.
Okay. Yeah, that's great. So if anyone has any questions, you can either write in the chat box or just raise your hand. Okay, I think we have a question here. Um, what is your advice to the master's first year students in the current scenario?
Okay. Uh, Advice in terms of jobs and career? If so, then I can answer that in that way.
Yeah,
Okay.
it's that's
See, as of now, in the current this situation, what is happening is all oil and gas companies are going down. Okay, that is the current scenario. There are no jobs in oil and gas companies, and oil and gas consultancy companies also. So the only thing that is rising is the this pharmaceutical companies, then water treatment companies, and environmental companies. So what I feel is you can, when you're looking for a job or something, try to look into these companies. FMCG companies also are good options, like PNG and all that. So you have options also, various options available in this field.
great. Any other questions? If someone has something to ask, you can also raise your hand. None. We'll just wait for 2 minutes if we have any other questions, and then we'll end this. I think the session went really nice and it was really insightful and fruitful, Farah. Thank you so
Yeah,
much.
yeah. If anybody has any questions, they can just mail me also. I can answer them, no issues. I can. I have not shared my email address. I'll just. I don't know where to share. Should I type it in the message here?
Yeah, you can type it in the chat box. Okay. Ananya has a question. Did you face any challenges as a woman?
Yeah, I'll answer that. Just hold on.
Any stereotypes or notions?
It is there. Definitely, it is there when it comes to the challenges as a woman. People will think that you might not able to do that kind of job, and they will try to, they'll not give you that. See, even if they don't tell you on your face, you can read it. Okay, that they are thinking, okay, fine, these are girls, so they can't do it. But it's not like that. Trust me, in my department, we have around, if there are people of, in department, I'm telling, 15 people, around 8 are girls, and they're doing very well. In fact, they do very, very sincerely. Okay, I'm not, discriminating anyone, but this is my observation. So I'll definitely encourage them to do. Okay, but yes, it is there. But it doesn't mean that it is there, so you have to choose another career or go in another direction. No, no, you have to be strong and hold yourself there. Okay.
Right. So, are there any particular kind of stereotypes like for chemical engineers?
Okay. They feel that we do a lot of mistakes. Okay. Calculation mistakes. They'll tell us to, check it twice, again and again, because they have that, okay, she might do the mistake. That thing is there.
Mm. Okay. Any other questions, audience? Anything else? Mm. If you have any other questions, you can mail Farah. She's given her email address, and I think we'll end the session now.
Okay.
We do not have any other questions.